Let's go ahead and dive into how to find the limit at infinity, but algebraically this time. So usually we're going to be dealing, when we deal with this, with rational functions, because that's what's going to cause that horizontal asymptote as we saw in this last section here. So here's a rational function. So what do we do? Now we got to go over the main idea, the limit, and I'll add that in right here. The main idea is that the limit as x goes to infinity or negative infinity, the same thing will happen, of 1 over x equals 0. And if you think about this, what happens is x gets really big. Well, we would have, if we made a table, x, y, and then, when our x is 1, we'd have 1 over 1, which is 1. If x is 10, we would have 0.1. If we divide 1 divided by 10, get 0.1. Or 100, we'd have 0.01. And 1,000 would be 0.001. And you could see as we go way out to infinity, what's this number going to be doing? It's going to get smaller and smaller and smaller, closer to 0. So the limit as x goes to infinity of 1 over x is going to be 0. Now we're going to use this idea to evaluate these limits. So what I'm going to do is I'm going to look at all the powers in here, limit as x goes to infinity. I'm going to look at all the powers and pick the highest power, and this has a power of 1. So the highest power is 3. So I'm going to divide everything by 3, or x to the third. So check this out. We'll have 3x cubed minus 5x, and I'm going to leave some space there, x cubed minus 2x squared plus 1. I don't know why I put the equal sign yet. I'm going to have to rewrite that. Anyways, so I'm going to divide everything by x cubed, the highest power. And so this equals the limit as x goes to infinity. And from here, I'm going to simplify everything. X cubed over x cubed, that's just 3. X over x cubed is just going to be 5. That's going to be 5 over x squared. Then here, x cubed over x cubed is 1. X squared over x cubed is, that's going to be 2 over x. And then we'll have plus 1 over x cubed. So now we're going to bring in this idea. The limit, if we take a number, I don't even care. If this was 1,000, eventually, as x goes to infinity, this is still going to be 0, because the number on top is not even going to compare to infinity. So when we divide by infinity, it's still going to be 0. So when we look at this, 5 divided by infinity is going to be 0. 2 divided by infinity is 0. 1 divided by infinity is 0. Infinity cubed, even bigger, right? So this is going to be 0, this is going to be 0, this is going to be 0. Those are just going to 0 out. This will equal 0, this will equal 0, and this will equal 0. And we're going to be left with 3 over 1. And that's how you evaluate these, which that's just going to be 3. Let's go ahead and do another example, see if we get this idea down. Basically, I have 3 different cases. I'm hoping to go over each one. So here, x cubed, once again, is the highest power. So I'm going to have 4x cubed over x squared plus 20x. And we're dividing each one by the highest power, x cubed. And sometimes these will say negative infinity, but when you divide by negative infinity, still it's going to go to 0, just as the other one did. And so when we simplify this, that's going to leave us with 4 on the top, and then 1 over x, because x squared over x cubed, plus 20 over x squared. And this one gives us an interesting answer, because what you'll see is that this will end up equaling 0, this will end up equaling 0, and we're going to be left with 4 over 0. So this one we're going to say is unbounded. It's either going to go to positive infinity, or it's going to go to negative infinity. And further tests would need to be done if we needed to determine which one it's going to. But for this assignment, I think we're just going to say unbounded and call it done. One more case we can run into. So once again, our highest power, this time it's not x cubed, this time it's x to the fourth. So we're going to divide everything by x to the fourth. And honestly, sometimes you guys can figure out a pattern to these where you don't even have to go through this step each time. So if you see that pattern as you're working through them, that's fine if you want to use it. Okay, so this is going to go to 0 here, this one will go to 0, this one will go to 0, and this will go to 0. So what we end up here with is 0 over 1, which is 0. So that's the case of 0. Notice the power on top is less than the power on the bottom. Notice we got a number when the powers were the same, and then here we got unbounded when the power on the top was greater. Just something to kind of think about as you go through those, if you're trying to find that pattern.